Thanks, Charles, and welcome everybody to this webinar. Today we're going to be looking at how to import the as-built data from the contractor. Let's have a look at this. This is the design, and I've given this to the contractor before the construction started. We're going to import the information that the contractor has built, the as-built information, in a bit later. But let's quickly send this out to CAD. I would like this to be a CAD line and the Z values to hold the invert levels. I would also like the diameters of the pipes to go through. I'll go through to the display settings and make sure only the items that I want through to CAD will be shown and displayed. So I'll make sure that the 3D entities are switched off. I'll go through to the nodes and just remove that for now. And I'll go through to the links and just change that to diameter. I also want to make sure that the catchments are not showing. Just one extra thing I don't really need at this stage for the CAD drawing. I can now publish this out because I've got my sizes and I've got my pipes. I'll go to plot generate. I'll make sure that I'm using the CAD sheet file. You'll find it at this location. And I'll take the CAD plan sheet file. I'm going to make it as a separate drawing, turn the survey on and make sure it plots it in 3D. So those pipes inverts will be plotted in 3D. I'll just redefine all and quit. That just clears the schedule. I can then press the add button, zoom out a bit, see where I want this to be, and I can accept it. I can also just check the grid settings. That's if you're going to send it out to a different consultant and you want the coordinates to be exact. I'm going to save this as a 3D. So this will be a CAD image of my 3D model. Okay, that's saved out, and that'll be a separate drawing which we will look at a bit later. I'm now going to quickly start a new stormwater model. So I'm going to go to File, Project Settings. I'm going to go through to the stormwater. I'm going to just call this as built and press open. Say yes and say okay. So now we need to import the as-built information from the contractor. One thing that I always like to quickly check before importing the information is to go to Edit, Default Settings. These default settings are the global settings that will be used for either when you're graphically drawing in the model, converting it from CAD, converting it from GIS, or converting it from a spreadsheet. I'm going to make sure that all of the items are a 1800 round precast, and I'm going to use drop as my manhole condition, but you are welcome to use invert, soffit, or half pipe. And my type of pipe that I'm going to be using is the 50D, and the diameter that I'll be using will be the 450. I'm going to use 450. Now, in the spreadsheet, there is a column for size diameter. If that column is left blank, it will take the diameter from here. I'll use the bedding class B and number of pipes 1, minimum cover. These I'm not too worried about because it's going to get the cover level from the natural ground and the invert from my spreadsheet. I can then press OK. Great, so let's look what the contractor has given us. We're just going to go to Excel and we can open up the as-built from the contractor. So you can see they've given us the node's name, the node to which the water then flows to, the Y, the X, and the invert level. If there is a drop manhole, then you need to put a slope and put the slope of that manhole going into the next manhole so that it will create a drop manhole for you. We can then close this. We don't need to save. Go back to Civil Designer and we can go inside Civil Designer. We've created the as-built. So we can go to stormwater mode and we can go File, Import, ASCII. We can then choose the file. I'm going to choose that it's a tab delimited file. And it's going to ask us what each item is. So The first one is your node name. The next one is the node that it's flowing to, so it draws your link in. Then we've got your y coordinate, your x coordinate, and your invert level. Fixed invert. If it was a drop manhole, you would need to either put in the slope or the fixed ratio slope. We can then say finish, and it brings in the pipes for us. We can then go to analyze network, and we need to calculate the link length from the coordinates. You can then see your flows. Well, you won't be able to see the flows because you haven't tied in a catchment to it. You can then select the item and go to Storm Operators, edit long section, and you can see your long section with all your manholes being connected. You will see in this case it's come through as drop manholes. If that is not the case, you can always select the item and change it to an invert. You can also change, if you want to mass change them or branch change them, you can go and graphically mark upstream. Graphically mark clear, graphically mark single, branch, upstream, all, or clear. So let's do upstream, replace existing. So it's doing the upstream from that, and I can then go tools, set parameters, and change all of the marked ones to invert condition. I can then go to graphically mark clear. I can then go to analyze network. Tools vertical alignment, and there you can see it's changed the upstream to be invert, while the downstream still remains to be a drop manhole. Great, so that covers that section. Once you're happy with your layout, you can go to your settings. We can go to nodes, put the name on, perhaps put the invert level and the depth. You can put a box around that. And we can go to the links. We can place the length in meters, and below it we can maybe put the slope. I don't want to have a box around that. And then you just need to move the text to where you'd prefer to have it. When you've moved all of that, you can then go to plot generate. I'm going to use the plan sheet file. I'm going to create a dynamic inside the project itself. I'm still happy with this. We can just click on move to see where it is. That's okay. And I can click on next. I'm going to put the stormwater list on. And here you can see we've got the list showing the names, the manhole types, the node sizes, as well as all the setting out information for the contractor. So this information isn't populated. Let's go and have a look at how we can sort that out. I'm going to go to my node types. I'm going to specify a 1800 round, and we can put a lid on that. And we'll make it concrete. So we're going to press OK. We can then go to graphically mark all. We can say tools, set parameters. We can change the manhole types all to be the 1800 round. Press OK. We can then go analyze network. This time I'm going to renumber branches, recalculate lengths, but keep the previously calculated levels and link sizes. can then go back to my plan. There you can see it's updated the node type and size. You can individually change each one. If you go back to your model, you can, let's just go graphical mark clear. You can select individual ones and go to your edit node data and you can change your type. You can also change it in the normal properties over here. You can also change your type of manual here. One way to update all these callouts is go back to the drawing space, go to your display settings, nodes. We'll change the text origin to be to the top right, and we'll change these to be 3 and 3. You can decide the ones that you've manually changed. If you want to override that, you're welcome to clear the manual offset, so we can choose that. And you'll see everything's now 3 and 3 away. You can just go back to the 1 or 2 that you want to place at a better location. Okay, and if you go back to your plan space, you'll see that it's all updated. Great, now that we've shown you how to create an as-built drawing for the client, let's go and have a look at how to get this out to BIM for the companies that want your data in a BIM format. So I'm going to go back to my layout and I'm going to show you the different methods. One of the methods is in your stormwater. We can go to File, Export, and we can export these to shapefiles. Many of the municipalities prefer having it in a shapefile format. So let's quickly go and say shape files, and we can then go over here and we can call this Flushing Meadows and we can call this GIS, and we'll press save. Let's go have a look. If I press Windows E and we go to the demo datasets, you'll see that you've got your links and your nodes saved into GIS format, the different types of GIS format available. For those that are wanting to send this out to BIM 360 or Revit or IFC or BIM Vision, let's have a look at the way we would export this out as a 3D model. You'd probably want to first make sure that you're happy with all the 3D symbols as well. We wouldn't be sending out the text, but more like the infrastructure itself. So if we right click and render view, you can see that all of these items are manholes. We probably want to update this and change them. So I'm going to quickly first go to my terrain. Just want to switch that off for now. And I'd like to also go back here to our 3D entities. You can see that this is a manhole. It needs to be a catch pit. So let's have a look at the properties. And we'll see that there isn't a catch pit here. So let's escape and go to edit node types. We can then create a new node. We'll call this stormwater catch pit. And we'd probably want it to be rectangular. We'd enable auto sizing. We'd make it brickwork. And we would give it a concrete lid. You can then change different aspects. And if you look at the display, this is the 2D symbol. So we could probably give it a different name. I'm going to give it a square looking one. when it's in 2D mode. At the moment, it's in 3D mode for the plan view. Auto sizing, you can change your different pipes coming into the manhole or leaving the manhole. If the biggest size increases, it can change the size and the dimensions of the chamber. We'll leave the user fields for now and we'll press OK. It's just telling us that if there's any changes, it'll only take effect after you've run analysis. So let's have a look at this manhole. Let's change it to that catch pit that we've just created. And we can see that we've got the orientation is not correct. So we'll just change that. And we want to update our cover levels. So you'll see here that it's not taking on the shape of the road. So I'll go to settings, DTM surface, and we'll ask it that when it's in the footprint of the road, whether it be the roadway or the sidewalk, to get its elevations from the road's final design. We'll then go to graphically mark all, and we'll go to graphical cover levels. We'll choose to again get its levels from the road when inside the road footprint. And we can now just check on this. See, its orientation has changed. But we'll figure this out. Right, that looks right, but I'm not sure if it's close enough to the curb. You can only see that in the render view. So I'm happy with that spacing. You could probably move it back a few millimeters. We can do that now quickly. So if I pick it up, I can move it back slightly and re-render it to see what it looks like. I'm much happy with that, and you'll see it's taken on the grade of the sidewalk as well. Okay, so we can export this now. So let's say yes, and this can probably go back to the 2D model. You'll see it takes on the symbol of a catch pit for the symbols. We can now go into CAD mode and we can go File, Export, IFC. So this is when you're creating a BIM model. We would like to export the terrain and the stormwater. Export each module separate IFC. I'll say no. Export the CAD mesh. I'll say yes, because we want to export the infrastructure like your manholes and your catch pits that'll go through as a CAD mesh. We're in the southern hemisphere, so we negate the coordinates. You don't have to worry about that for northern hemisphere. And we would like to, then we're not doing anything with the roads, so we can now choose a location for this. So I'm going to create this Flushing Meadows. This is the stormwater and the DTM. And we'll do that as an IFC file. We're don't have to do the naming standards yet, and we'll be doing IFC 2.3. If you're using BIM Vision, you can use IFC 4. If you're sending it to Revit, then you need to use IFC 2. Don't have to worry about the catalogs. If you are using the catalogs, you're welcome to, and the IFC properties you can also work with as well. So these are all the information that will come through in the BIM model as well. So let's do the catalogs as well. So that's created that BIM model. So we can go and have a look at it in, say, BIM Vision. Here it is. So we'll just bring this across. and we can go to File, Open. And here's the stormwater and DTM model. So you can see here's all we didn't bring the roads through this time. So you can see it's brought through all the infrastructure. You can also click on the infrastructure. Let's just expand this. And you can see that's a stormwater catchment that we just named earlier. And you've got your cover level as well as your invert level. So this is the information that would be needed for the contractor to build it. And just location information. Great. I hope that helps you with exporting it to BIM. Let's go and have a look at some of the other aspects of the as-built drawings. I'll just go back to our main model. And we can switch back on the terrain. For those of you that want to compare your design versus your as-built, remember earlier we saved the design as a CAD drawing. Let's go and import this CAD drawing as a 3D model. Before we need to do that, we just need to set up a few of the CAD items. We need to clean up that CAD drawing. So I'm going to go to File, Open, and I'm going to go through to the CAD drawing. Great, so we'll just open up this file that we created earlier today. We're going to isolate the storm model in a moment. Just go to the properties. So that is the storm link and the storm link text. So I'll right click over here and I'm going to rename these. So this is the storm link. I'm going to rename this to the storm design links or pipes, whichever you choose. I'm going to copy that and paste that into the storm link text, but instead of, I'm going to have your diameters here. So I'm going to make that the current, and then I'm going to say current only, but I also want to show the links as well. So now it's isolated. Now we have some items we need to delete. Here's a solid, so I'm going to right click and say select same type, and then delete those. And then we have, I'm going to do a crossing selection here and then hold down the control key and run another crossing selection. So we've got lines. So I'm going to do a select same type again and delete. Now we're left with polylines. So I'm going to right click, select same type, and I'm going to rename, I'm going to explode those once. And now we're left with lines. So each line has got a Z start and end. So that will represent the invert level. And then we've got the text. It's not multi-line, it's single line text. And it represents the diameter of the pipe. So that's a schematic that can then be converted into a 3D model. So I can go and save that. Or if I want to, I can select it and go File, Save Options, Save Selected, and save it as an independent drawing. So you don't have to purge or have any other unnecessary CAD layers in that drawing, completely separate from anything else. So now we can go to our model, back at our main model where we've got the as-built, and we want to load in a model of the design. So I'm going to go and load in those CAD layers. And they'll come through. I can then go to the roads mode and I'll go to tools, crossing services, and I'm going to convert from CAD. So here, this destination layer, you give it a name here, it'll come through. and I don't need the link names, the inverts. I'm going to, or the links I'm going to get from the CAD layer that I created earlier, and the diameters also from a CAD layer I created earlier. I'm not going to choose inverts, and I'm going to choose millimeters, not meters. So the reason I don't choose inverts is because I wanted to get the inverts from the CAD entity itself. So if you look in 3D now, we're above the road, so just go underneath the road. You can see there it has got the invert levels of those pipes from the entity itself. So you can see the red is what has been designed and the blue is the as-built. If we go to the road model, select the road and go to road operations and select the cross section. And then go through to your pipe crossings. You can see we've got the design versus the as-built. So you'll notice that the diameters are different because the one is an internal diameter and the one's an external diameter. So we'll just go back to our stormwater, have a look at our link tables. We are using the 50D. If we look at the sizes, you'll see the difference is about 91 millimeters. So divide that by 2, so it's 46 mils or so. So we need to add. So if we go back to the roads mode, we go to tools, crossing service editor, we go to the table. Here's the table. That's what we converted when we converted from CAD. We generated this table. And now I can just paste that, the new wall thickness into this item here, and then save that and go back to our crossings. You'll have to just reload it. There you go. The two diameters are now representing the external diameter of the pipes, and you can compare the designed versus the as-built. Great, I hope that was encouraging to you guys. Please let us know if you have any questions with regards to as-built for sewer and stormwater. I look forward to hearing from you guys. Have a great day further. Back to you, Charles.